In this section, we're going to talk about solving nonlinear systems of equations. But before we do that, I want to do a brief review of solving linear systems. There are two standard techniques that we use for solving linear systems. Now first, notice these are linear because there's no exponents on any of the variables here. That's what makes them linear. All right, so the two techniques are substitution and elimination. The way substitution works is you take one of the equations and you get one of the variables all by itself. So for example, for this problem, it would be easy to get y all by itself. Y equals negative 2x plus 5. And then this is called substitution because I take that answer and I literally substitute it into the other equation. I'm going to have 3x plus 5 times negative 2x plus 5 equals 4. A little bit of algebra here. 3x minus 10x plus 25 is 4. So that's negative 7x plus 25 is 4. Subtract the 25, negative 7x is negative 21, and divide, you get x is 3. You then take that, plug it up there, and you're going to have y equals negative 6 plus 5, which is, negative 1. All right, so our answer would be the point 3, negative 1. That's where those two lines cross. The other standard technique, like I said, is called elimination. And the deal with elimination is if I were to take either of these equations and try to get x or y all by itself, eventually I'd have to divide by a number, and that would introduce fractions, and that makes life a little bit harder. We like to avoid fractions when we can. So rather what we do is we set the variables up to eliminate. So to make them eliminate, I'm going to take this first equation and multiply it by negative 2. So that gives me negative 4x minus 6y equals negative 16. I'm going to leave the first equation alone. Then I'm going to add the two equations. And notice what happens. The x's add up to 0. So this is why this is called elimination. We set it up so that we eliminate one of the variables. All right, so we add, we get 0 x's, we get, that's a y right there. We get negative 11y equals negative 44. So we divide y of 4. We take that and plug it into one of the original equations. It doesn't matter which one. The first one looks like it has smaller numbers, so I'm going to use that one. 2x plus 12 equals 8. So 2x is negative 4, x is negative 2. So these two lines would cross at the point negative 2 comma 4. Okay, so now we're going to talk about nonlinear systems, and we'll see that basically we use exactly the same techniques. So here's a nonlinear system. We recognize it's nonlinear because we have things with squares. Now we should recognize what kind of equations these are. Y equals x squared minus 4, y equals 4 minus x squared. We should recognize that those are both quadratic. They're parabolas. And I think you would agree that parabolas could potentially cross at more than one point. For example, in this situation, y equals x squared minus 4 looks roughly like this, and y equals 4 minus x squared looks roughly like that. So it seems as though it's likely we're going to get two answers. Now, with two parabolas, you might not get two answers. I'm just going to draw a picture here. You could potentially have a parabola that looks like this, and maybe another parabola that looks like that. And it's possible that they cross right at one point. Of course, I could have drawn the second parabola a little lower and they wouldn't have crossed at all. So, when you're dealing with nonlinear systems, it's difficult to know how many answers you're going to get. You just have to go ahead and solve. All right, so I'm going to go ahead and solve now. What's nice about this system is each of them are already solved for y, so I can take that one and plug it into that one. I have 4 minus x squared equals x squared minus 4. And now we have to solve the quadratic equation. I'm going to add x squared to both sides. So 4 equals 2x squared minus 4. Then I'm going to subtract 4. 0 equals 2x squared minus 8. And then I need to solve. I think I can solve this one by factoring because I noticed that I can factor a 2 out. And then I have 2 times x squared minus 4. And then I can factor more. Difference of squares. 2 times x minus 2 times x plus 2. This one tells me that x has to be 2. And this one tells me x equals negative 2. Now what I do is I take these answers and I plug them into either the equations, doesn't matter which one. I'll use this one. When I plug in 2, I get 4 minus 4, that's 0. So I get y equals 0. And when I plug in negative 2, I get negative 2 squared is 4 again. 4 minus 4 is 0. So it turns out that these two parabolas cross at 2 points. All right, let's take a look at the next one. X minus y equals negative 1, and y equals x squared plus 1. Again, we should recognize what kind of equations these are. This first one is a line, and the second one is a parabola. And again, I think you could draw some pictures to convince yourself that a line and a parabola might cross at 1 point, might cross at 2 points, or might not cross at all. This time to solve, I think I again would use substitution. I think I would take this equation and add y to both sides. So I would have x equals y minus 1. And I would then substitute that into that equation. So y equals y minus 1 squared plus 1. Now be careful here, you've got to FOIL this out. Think of this as y minus 1 times y minus 1 and expand it. You get y equals y squared minus 2y plus 1, and then you still have this other plus 1 on the end. A lot of students will say that this is y squared minus 1. You can't do that. Write down y minus 1, and expand it out, and I promise you that this is what you'll get. All right, so if I subtract the y on both sides, I get 0 equals y squared minus 3y plus 2. And once again, this is pretty good because I think it factors. This is y minus 2 and y minus 1. So y equals 2 or y equals 1. And I can take and plug in. And I can plug into either equation. I'm going to pick this one because it certainly looks easier to me. When I plug y in here, I get 2 minus 1, so x is 1. I like to put the x's on top. And when I plug 1 in here, I get x is 0. So I should probably be writing my answers as ordered pairs. So one answer is 1, 2, and one answer is 0, 1. I probably should have done that back up here too, so I will. One answer is 2, 0, and the other is negative 2, 0. All right, this last one. On this sheet, there's more to this video. There's a part 2, by the way. X squared plus y squared equals 25. Y equals 2x minus 5. Again, I think I can go ahead and solve because I have y all by itself on this one, and I can take it and plug it into that one. So x squared plus 2x minus 5 squared equals 25. Again, be careful about expanding this out. Write down 2x minus 5 times 2x minus 5 and write it all out. To save a little time, I have a shortcut formula that we did talk about earlier in the semester. I'm just going to use the formula. This is 4x squared minus 20x plus 25 equals 25. Combining my like terms, I get 5x squared minus 20x. And then I'm also, at the same time, going to subtract 25 on both sides. Both happen to reduce out. I get 0. Factor. 5x times x minus 4 equals 0. So I get two answers. I get x equals 0, x equals 4. Plugging in, if x is 0, y is negative 5. And if I plug in 4, I get 8 minus 5, that's 3, y equals 3. So my answers are 0, negative 5, and 4, 3. Now, just out of curiosity, I'm going to take a second, and I'm also going to go ahead and solve this one on Desmos, just to see how well you can use Desmos to also solve these kind of equations. All right, as I said, I wanted to take a minute to show you how to solve these using Desmos. We have x squared plus y squared equals 25. And that's a really nice feature of Desmos, that you can type the equation in that way. You don't necessarily have to have y all by itself to type in equations. And then we have y equals 2x minus 5. And I don't think I mentioned it before, but we should have recognized that x squared plus y squared equals 25 is a circle. Should have known that. All right, now we find our answers. We see they cross at 2 points. So we see one point is the answer 4, 3. And the other point is the answer 0, negative 5. And those do happen to be the same answers I got when I did it by hand. That's a good sign. That always tells me I did it right. Okay, now there is a part 2 here. I'll do some more nonlinear systems examples where we end up using the elimination method. So make sure you watch part 2 of this section.